Okay, so section 5.6, graphing rational functions. This is the last section in chapter 5, so we already did 5.8, 5.9, 5.10. We're not doing 5.7. Excuse me. And we're going to finish 5.6, and that'll be it. Now, 5.6 has to do with graphing, okay? Now, before I get into what these functions look like when I graph them and what they look like in terms of an equation, let me remind you of something you guys should already know, okay? So, when we did quadratics, okay, quadratic functions, or we just call them quadratics, the equation that we used to graph it looked like this. And I'm hoping you guys are like, oh yeah, I remember that. Actually, let me change this right here, because I'm trying to make a point with it. I'm going to change some of the colors really quick, okay? So this will be A. I'll make this H, K. You guys remember that one? What was the A for? You guys remember? It tells you whether it goes up or down, and also the A stands for, not slope. Well, it does kind of give you your slope the first time, but it stands for amplitude. How fast it can grow up or maybe slow down. So if it's like a fraction, it opens up real slowly. If it's like a number like 5, it goes up quickly, right? But A is our amplitude. But it does tell us whether it opens up or down. It flips it, right? So I'm going to use that really quick. I'm going to say A tells you whether it goes up or down, and I'm going to put in parentheses, it flips it. Okay, it flips the function. And you guys remember what H and K were? The vertex, right? H and K, this is our vertex. All right. Now, aside from, now I'm not going to go into anymore. Like, I just want you guys look at that. Okay, focus on that. Now, we also did absolute value functions. Absolute value functions. And those equations look like this. I'm going to finish writing it out right now. Just give me a second. Now, those look pretty much the same, right? The only difference is that one of them has a square term and it also has parentheses instead, right? Instead of a straight line. But the A and the HK are the same thing. A tells you whether it goes up or down. I'm going to write that down right here. So A tells you whether it goes up or down. And I'm going to put right here, it flips it. And then HK was our vertex, the pointy part, right? The pointy part. But I know that these are two separate lessons, and I know some people took these as completely different ideas. But when you look at them, they're pretty much the same thing. The picture just looks different, right? The picture looked different. For quadratics, our graphs look like this. For absolute values, our graph looks like this. Okay, so now I'm going to introduce rationals. Okay, bless you. So I'm going to introduce rationals for you guys. And the graphs don't look anything close to this, but it's okay. We'll adapt to the way the graph looks. Okay, but I want you guys to know how close the equations still kind of look. Now remember, these are rationals, so they're going to be fractions. Okay, so this is what we're going to be doing today. Rational functions. All right, so this is what it looks like. Y equals to, and right now fill in the blanks. So would you say it kind of still has the same basic form of things that you're supposed to focus on, A, H, K? Right? It's still there, right? Bless you. It's still there. Notice All three of those equations have that, right? They have an A, they have an H, they have a K, right? A is still going to be my amplitude. It still tells me whether it's opening up or down, but this doesn't really have an up or down because of the way it looks. So we're going to say it either looks normal or inverse, right? Reverse. But we'll just put up and down. It doesn't hurt. All right, so we'll say that A is still our amplitude, okay? So A will tell us whether it's opening up or down, but you'll notice it does both, okay? So you're going to think of it in terms of flipping it. That's why I use the words flipping it. So it flips it. Okay, and I will draw what the normal graph looks like right now after I'm done writing this down. Now, our HK is supposed to be our vertex, okay? But it's not here. HK is the point where the asymptotes cross, okay? So I'm going to put right here, point where the asymptotes, very weird word, cross. Do you guys remember or do you guys know what an asymptote is? These are like vertical lines or horizontal lines, in our case it's going to be both, that you cannot cross. They can't be crossed. So it kind of traps the graph in certain areas. It traps it, okay? So these are lines that cannot be crossed. So I'll put the definition right here. So asymptotes are lines that cannot be crossed. And I'm going to put right here, they can be approached. So they can be approached. So lines that cannot be crossed, but they can be approached. That means you can get real close. For which one? Oh, the graph can't cross it, but the asymptotes can go through each other. Because asymptotes are invisible lines. We're going to draw them, but they're not there. So when they cross, they actually aren't crossing. They're not there, right? But we're going to visually do it, and it's going to help you graph it. So, and when we draw the asymptotes, they're going to be dashed lines so that you know, like, they're not really there. So are they really crossing? They're not really crossing because they're not there. But we're visually going to be able to see it. So by saying where they cross, it's going to give you an idea of like, oh, here's a point, so I'm going to make a vertical line and a horizontal line right through it. So that I'm trying to make it so it's easy for you guys to do your graph, but you're correct. The lines don't actually cross, and that's true, they don't. But these the point HK, where it's at, is actually not even there. It doesn't exist because they're asymptotes. So
asymptotes that cross each other, that they can cross the HK?
The asymptotes never cross each other. They're not there. We're going to show it to you. You're going to see it, and they'll be denoted by dashed lines, so like invisible lines, right? The only thing that cannot cross the asymptotes will be the graphs themselves when I draw the graph. So right now when you see it, let me show you. Let me show you what one of these graphs is supposed to look like. I'm going to do two of them, okay? So one of them is going to be with the positive A, the other one's going to be with the negative A. Right here I'm going to put A is positive. Okay, if A is positive, and this one will be A is negative for the second one. Okay? So the normal equation, 1 over x, that means, so this is the basic function. So I'm going to put right here, f of x equals to 1 over x. This will be f of x equal to negative 1 over x. Okay? If it's just 1 over x, that means that my a term is 1, and my hk are 0, 0, because they're not there. Okay? H and k are 0, 0, because it's not there. that means that my asymptotes are at the origin, meaning they're going to cross 0, 0 like this. So I know it's kind of hard, so I tried to show it to the side of the line just to try to make it a little bit more obvious. Those are my asymptotes. They're not really there. You don't see them, but you do, okay? But you're not supposed to see them. But we draw them because we need guidance, okay? Now here's the graph of the line. It gets really close like that. Don't let them touch the red lines, okay? That's what it looks like. That's what 1 over x looks like, that green graph. That's the normal look for these graphs. It looks weird, okay? But you're going to have, it's going to be quadrants 1 and 3. In 1, it's going to curve like this. On 3, it's going to curve like this. So notice how when I say it opens up and down, like this graph is kind of weird because it doesn't just open up. This one's opening up, this one's opening down. They do that. The red lines are the HK. Notice in this equation, HK is 0, 0. So look where I made the red line cross. Right? They're right there at 0, 0. Right? Notice I didn't put a dot because there's not supposed to be a dot there. But it's my mental reference that this is where they're going to cross each other. So then I'm going to draw my horizontal dashed line, vertical dashed line right there. Okay? And then all I have to do is draw the green part. Notice, did I do any calculations for this? No, I just said I know what the picture looks like. Once I get my asymptotes up, I'm going to draw my line, and I'm done. That's it. Move on. Okay? This one right here is going to look identical to that, but when it's negative, I'm going to flip it. So it's still going to have the same red dashed line, but the green line from quadrant 1 is going to go to quadrant 4, and this one from quadrant 3 is going to go up to quadrant 2. So this is what this one is going to look like. So I'm still going to have my asymptotes going through the point 0, 0. Again, don't put a point there, because if you put a point there, then you're actually going to end up getting it wrong. And oh my gosh, let me pause this thing. All right, so sorry about that on the video. It's just the pen froze up. But I'm drawing my vertical line. Again, I'm kind of drawing it to the side of the x and the y axis. That way you can see it, because if not, it's right on top and you may not notice it. So I'm trying to make it obvious. Okay, so it's supposed to be crossing through 0, 0. Again, I know these two lines are crossing each other, but again, these two lines are not really there. They're only there because I'm drawing them, but they're not supposed to be. If you had a graphing calculator, they wouldn't show them. Okay, it wouldn't be there. So, all right, all I got to do now is get the top picture and flip it, because it's a negative 1 over x, right? A is negative, so I'm just going to flip it. So all I'm going to do is this part is going to go like that, and this part is going to go like that, and there you go. Okay, I'm at the mercy of those dashed red lines. Okay, that's what tells me, hey, this is how you draw it. Okay, but this is literally, guys, this is all the work you have to put into doing today's work. Okay, you're just going to identify whether it's normal looking, A is positive, or if it's reciprocal of it, it's because A is negative. And then where do I create these dashed lines? That's the only thing you have to figure out. After that, it's just follow the picture. It's either going to be like the top one or the bottom one, lined up to your red asymptote line. They always do that. So right now, let me do some examples so you can see. It's always going to be like that. It's always going to look like that. So now, if you want to know exactly how to do it, you can pick tons of points. You can pick like 6 points to the left of the vertical asymptote, 6 to the right, calculate every single one, put your dots in there, and then you'll know exactly where they go. I'm trying to get you guys to do it by just sketch. So just kind of based on the way it's supposed to look. So remember, if A is positive, so maybe you want to write this down for you guys, and I'll put it right here for you guys just so you remember. If A is positive, it's going to be on the, if I can, I'm going to use BL and TR. Bottom left, top right. Okay, if A is positive, it's bottom left of the asymptotes on the bottom left box. And then TR, top right, for the top right of the asymptote box. So you'll see a little bit better right now once I do this. For this one right here, it's going to be top left and bottom right. Just memorize the top one and then just know if it's negative, just flip it. Just flip it over. So here we go. Let me show you an example here. So these are all from your homework. Example number 1. All right, so we'll try one that looks normal first. So we're going to sketch. They're going to tell you to graph, but I'm just going to tell you sketch. And we're going to sketch this. F of x equal to 2 over x plus 2 minus 3. Okay? Let me draw a graph here. The only thing that matters, the way I want you guys to learn this, the only thing that matters is where are the asymptotes, okay? So in other words, all I got to figure out is where is HK, all right? Once I know where HK is, I can draw those red dashed lines, and then once I draw those, I can sketch my graph. I don't have to do any work. So, what's HK? 2, negative 3? Close. Negative 2 and negative 3, because H is a liar, right? It still follows all the same rules. Negative 2, negative 3. So I'm going to go to negative 2, negative 3. I'm going to put a little dot there just for reference. I know you can't really see it, but it's there. And I'm going to use that to draw my asymptote. So here we go. Negative 2, negative 3. So there's that. That. All right. Now focus on the dashed red lines. Ignore the black lines, okay? The black graph, ignore it. Focus on the red dashed line. Now my A is 2, right? So A is positive. So if A is positive, I'm supposed to graph it according to this red box on the bottom left and the top right. So here you go. And then I'm done. That's it. I'm done with this problem. So top right gets the graph. Bottom left gets the graph. And that's it. I'm done with that problem. All right, so let's go to example number 2 here. By the way, before I move on to this, does anybody have any questions on the one I just did? On this one right here. You mean explain anything on it? Again, don't get distracted by the black graph axis. Your focus is on the one you drew in. Okay, the dashed red line. That's where you focus in. All right? So we're good? All right, so here's one. This is the first one in your homework, so we'll do that one. We'll create a sketch. They'll give you guys a place to draw it, so don't worry. Just pretend you're playing COD or Fortnite and you're trying to figure out where you're going to aim your scope. That's what you're doing, right? You're trying to aim your scope somewhere. So, what is my HK here? All right, so negative 1, breathe, thank you. And A is what, positive or negative? Negative. So normally it's supposed to be on the top right and the bottom left like this, but since it's negative, it's going to flip. It's going to go this way, right? It's going to flip around. So, all right, let me draw my asymptotes. So negative 1, 3, the point negative 1, 3 would be here. So I'm going to draw it right there. Again, I'm not putting a point there because there's not supposed to be a point. Okay? And here's negative 1. So again, ignore the black graph. Okay, the whole coordinate plane that's in black, ignore it. Focus on the red one now. That's your new section where you're going to graph. Now, since this is negative, then you're going to draw it on the top left and bottom right. The top left and the bottom right. So here you go. Like that. And like this. And notice how I'm not touching those red lines, right? I'm making sure I don't touch them. That's all you have to do. Just know which way it looks. When A is positive, how does it look? When A is negative, how does it look? Excuse me. And once you have that, there's no calculations. The biggest calculation you have to do is mentally list your HK. That's it. There's no like work to do. And it's not like there's going to be another one in the back that's even harder. Like, no, that's pretty much what they're like. Now, let me give you one in the back that they might try to trick you with, but it's not that it's difficult. But before I do that, any questions on this one? So it got flipped, okay, because A is negative. We flipped it, okay? All right, example number 3. So we're going to sketch this function right here. So I'm going to go ahead again and draw a coordinate plane, the original one, even though I don't use it, but I use it just to get like some idea of where my asymptotes are going to be. That's as far as I use it. My goal is to get those red dashed lines in there because that's what I focus on. All right, so what's my HK here? -2, 0. Okay, -2, 0. And then A is positive, so it's going to look normal, right? So -2, 0, that's 2 to the left, but no height. So that means that it's going to be vertically at -2 and horizontally at 0. So it's going to be like this, right on the x-axis, okay? So remember, the point -2, 0 is where both of those asymptotes are crossing each other. Again, they're not touching because they're not there. Okay, they're not there. Asymptotes are ghost lines, okay, but they are lines that we cannot cross because if you pick any number on any one of those lines, it basically makes the function explode, like it doesn't work. Okay, so now that I've done my little red graph right there, then I'm going to focus on that. I'm going to ignore the black coordinate plane, just look at the red one. And since A is positive, that means I should draw it on the bottom left and on the top right. Bottom left and the top right. So here you go. Now, if you happen to draw it and you kind of go back up like this, I won't say like, oh, you drew it wrong, you're wrong. Okay, because sometimes our lines aren't perfectly straight. If you do this, then yes, I'm going to mark you wrong. I mean, that's pretty badly exaggerated, okay? As long as you're kind of going as best you can in a straight line, close to the red line, I'm going to be okay with that. Just don't go curving it like a parabola, okay? Because then I'll be like, yeah, that's not right. That's not the right picture. But we'll do one more from your homework, one that's going to be negative. What do you guys think? Not too bad, right? All right, one more from your homework, and then I'll let you guys get to it. So, let me see. We'll do number 3. All right, so example number 4. By the way, on your homework, the instructions say graph each function, use the shift from the parent function. That basically means figure out your asymptotes to move it to a certain place and graph. Okay, so just basically sketch. That's all you guys want to do. Just sketch. So here we go. There's nothing wrong with graphing these things. Okay, I don't think it's important that you know how to graph them, but more importantly is you kind of know where it's at. And then from there, we have technology now that helps us do this. When I learned to do this stuff in high school, we didn't have that technology. So we had to learn like, okay, what does this graph actually look like? If I don't draw it myself, I won't know. But now you can just go to Desmos, type it in, and there you go. I don't know. I've heard that they might let you use Desmos within the SAT. So you'll be able to use it as a calculator. And if you can, that means you'll be able to graph. But I know they'll let you use graphing calculators. But yeah, I think if they allow a calculator use, a digital calculator use on the SAT, it's probably going to be Desmos. So it's a good calculator to get used to. All right. HK is what? 2, -1. A is negative. So remember, that's going to be top left, bottom right when you graph it, okay? So let me draw my invisible lines here. -2, -1 will be right about here. So let's see. One line goes there. The other line, -2, goes here. So it's right there. And then all I have to do is draw this in as a reciprocal, okay? So it's going to reflect on the horizontal axis. So it's supposed to be bottom left, top right, but since A is negative, I'm going to flip it. So now it's going to be top left, bottom right, okay? So top left, bottom right. And that's it. This is what your homework is like.